4. Chapter 44. Protection against voltage disturbances. Chapter 44 addresses protection against voltage disturbances, emphasizing the need to consider potential voltage-related risks associated with electrical installations. 4.4.1 discuss overvoltages of man-made and atmospheric origin and their effects on equipment. Overvoltages are transient increases in voltage that can damage electrical equipment and pose safety risks. Chapter 44 considers overvoltages from two common sources. Man-made events. Switching surges caused by switching inductive loads or faults on the grid system can induce overvoltages. Faults in the high-voltage system can result in temporary overvoltages in the low-voltage system. Loss of the supply neutral in the low-voltage (LV) system may also cause an overvoltage. Atmospheric origin. Lightning strikes can induce high transient overvoltages. These overvoltages can be transmitted through supply distribution systems. The term strokes is used to describe indirect lightning strikes that induce overvoltage in a network. Effects on equipment. Overvoltages can cause damage to equipment and pose a risk of electric shock or fire. Equipment is categorized based on its ability to withstand impulse voltages. Category I equipment is most sensitive, while Category 4 equipment is more robust. Equipment closest to the supply requires a higher category due to the increased likelihood of exposure to overvoltages. The impulse withstand voltage should be at least equal to the required minimum impulse withstand voltage according to the overvoltage category of the point of the installation. Overvoltage control. Protection against transient overvoltages should be provided where the consequence caused by overvoltage could result in serious injury or loss of human life. This includes electrical systems associated with safety services. Protection is also required where overvoltages could result in interruption of public services, damage to cultural heritage, interruption of commercial or industrial activities, or affect a large number of co-located individuals. For single dwelling units, protection against transient overvoltages is only required if a risk assessment determines it is necessary, or if the total value of the installation equipment justifies it. Surge protective devices, SPDs, are used to limit overvoltages and protect equipment. SPDs facilitate insulation coordination and protect against damage to current-using equipment. The lightning protection zone concept is used to determine the appropriate type and location of SPDs. Type 1 SPDs are installed at the origin for lightning current protection. Type 2 SPDs are used for overvoltage protection in subdistribution equipment. Connecting conductors between SPDs and the main earthing terminal should have a cross-sectional area of at least 6 mm superscript 2 copper for Type 2 SPDs and 16 mm superscript 2 copper for Type 1 SPDs. Understanding the sources and effects of overvoltages is crucial for implementing appropriate protective measures and ensuring the safety and reliability of electrical installations. 4.4.2 explain the concept of transient overvoltages and the importance of risk assessment. Transient overvoltages. Transient overvoltages are very short-duration voltage spikes or surges that can occur in electrical systems. They can arise from various sources, including lightning strikes, switching operations, and equipment faults. 4.4.2.1 These overvoltages can stress and damage electrical equipment, leading to failures, reduced lifespan, and safety hazards. Transient voltages can be caused by indirect lightning strokes, which are lightning strikes that don't directly hit the network, but induce overvoltages. Importance of risk assessment. A risk assessment is crucial for determining the need for overvoltage protection. The assessment should consider the potential consequences of an overvoltage, such as serious injury or loss of human life, interruption of public services, damage to cultural heritage, interruption of commercial or industrial activities, significant financial or data loss, affecting a large number of co-located individuals. If the consequences of an overvoltage are deemed intolerable, protection against transient overvoltages should be provided. For single dwelling units, a risk assessment is required to determine if overvoltage protection is necessary, unless the value of the equipment does not justify such protection. The risk assessment needs to be documented. 4.4.3 Cover mitigation of electromagnetic disturbances and considerations for undervoltage protection. Mitigation of electromagnetic disturbances. Electromagnetic disturbances, EMD, can interfere with the proper functioning of electrical equipment. Segregation of circuits is a key measure to reduce electromagnetic interference. This involves separating circuits that are likely to generate disturbances from those that are sensitive to them. Consideration should be given to grouping circuits based on their potential to cause or be affected by EMD. Considerations for undervoltage protection. Undervoltage is a reduction in voltage that can cause equipment to malfunction or be damaged. Suitable precautions should be taken where a reduction in voltage or loss of voltage could cause danger. This is especially important for circuits supplying motors, where undervoltage can lead to overheating and damage. Undervoltage protection can be achieved using undervoltage devices that monitor voltage levels and disconnect the supply if the voltage drops below a certain threshold. For equipment that may be damaged by a drop in voltage, it should be verified that such damage is unlikely to cause danger. Consultation with the personnel responsible for the operation of the installation can help determine if the foreseen damage is an acceptable risk. If the restarting of equipment after an undervoltage event could create a dangerous situation, manual restarting may be required. Appropriate coordination is needed, and devices that will disconnect for undervoltage events need to be selected. By performing thorough risk assessments, implementing appropriate mitigation measures for electromagnetic disturbances, and considering undervoltage protection, electrical installations can be better protected against voltage disturbances, ensuring safety and reliability.